Hey guys, this is the video lesson for 2.1 for trig special right triangles. So we learned about special right triangles back in geometry. I don't know if you remember all the way back to there, but the special right triangles had special relationships between their sides. So every triangle that had a 30, 60, 90 are similar. So all their sides always have the same ratio. So for what we're going to do now, we're going to use our sine, cosine, and tangent of those special values, and we use those all the time. So the special right triangle theorem tells us that for the 30, 60, 90, that the side across from 30, if it's a 1, then the side across from 60 is root 3 as big as that. So root 3 times 1 would be root 3. And then the hypotenuse is always twice as big, so that would be 2. For the 45, 45, we know that there's two congruent sides because it has two congruent angles, so those would both be 1. And then the hypotenuse is twice, or root 2 as big as those sides. If you did the Pythagorean theorem with 1 and 1, you get root 2, so that's another place it kind of comes from. So from there, we can fill in our table below and find all of our trig function values for those special angles. There are other sets other than the 45, 45, 90 and the 30, 60, 90 of special angles that have special ratios, but these are the only ones that we do. And these angles are really special. We use them all the time. Okay, so let's take a look. So if we wanted to find the sine of 30, if we use SOHCAHTOA, 30 sine is opposite over hypotenuse, so that would be 1/2. Okay, and then I'm going to jump down to the sine of 60 because it's in the same triangle. So the sine of 60 is root 3 over 2. Okay, so from there you could fill in the cosecant ones. We can look at this triangle for 45. So 45 would be 1 over root 2. And if we rationalize 1 over root 2, we get root 2 over 2. Okay, so I think you guys get the idea of what we're doing here. Make sure you rationalize your denominators. So pause your video, and when you come back, I will show you what the other answers are for the rest of the table. Okay, I hope you paused. So here we go. So using those triangles, we can find all those other values. So I hope we were noticing the patterns that happen here, like that the sine of 30 is equal to the cosine of 60. So the sine and cosine are equal when the angles are complementary. See, we have it here as well. These are equal too because the angles are the same. And there's other relationships between the other sets. Tangent's always, it's reciprocal, well, for the complementary angles. Okay, so this is not only what we're going to do with it, we're also going to look at triangles that are 30, 60, 90, and 45, 45, 90, and find their missing sides using those special relationships. So this is what we did back in geometry when you learned about 30, 60, 90. We didn't really talk about it in terms of the trig functions. We found missing sides. Okay, so our formulas are pretty much exactly what we have here, but we just put an x with it. So the formula for this side is x. The formula for this side is x root 3, 2x, x, and x root 2. Okay, so we're going to use those special ratios, patterns that are there to find missing sides when they give us just one. So let's take a look. Okay, so for my first triangle, I can see that it's isosceles because it has two congruent angles. So that means it has to be the 45, 45, 90 triangle. So we can write our formulas in. So as we wrote on the front, across from the 45 is always x, so those are x's. And then across from the 90 is x root 2. Once you write your formulas on your triangles, take your formula and equal it to the number that's there. So x root 2 is equal to 5 root 2. From there, we can solve the equation for x. And we get that x is equal to 5. So once I know that, I can plug it back in where I wrote my formulas. And we get that that side is 5 and this side is 5 because they're both x. We were given the hypotenuse, so we don't need to worry about plugging anything back in there. So that means that our legs, the two sides that are the same, are both 5, and our hypotenuse is 5 root 2. So I know that they had some letters on the sides. So I like for you guys to write it like this, legs, hypotenuse. But if they have letters, you might also want to add, like this was equal to A and this is equal to B. The reason I like to write it like this is because sometimes they put letters, like they use X all the time, and it might not be in the actual X spot. So it gets a little bit confusing. Okay, so let's flip over to one that's a little bit harder, and then you guys can go back and solve the rest on your own. So if we look at this one, we fill in our formulas first. So we know it's a 45, 45, 90 because we have two congruent sides. So both of those angles would be 45. The sides that are across from those get x, and the side across from 90 gets x root 2. So for this one, again, we were given the x root 2 side. So make your equation, solve for x. So do we remember the rules for dividing radicals? It's just like if you were multiplying, so you can only multiply the things inside the radicals. So here we can only divide the things inside the radicals. So we would have 2, 6 divided by 2 is root 3. You end up with the same thing if you rationalize, but then you'd have to simplify radicals and it's way harder. Okay, so once we get our x value, we just plug it into our two sides. So both of the legs are 2 root 3. 2 root 3. So if we make our list, the legs are 2 root 3, and they were x and y, and the hypotenuse is 2 root 6. Okay, I guess we should do one that doesn't give you the hypotenuse. So for this one, fill in your formulas. We have x, x, x root 2. Make your formula equal the side you were given. So we were given this side, so we know x right away. So we don't have to solve an equation because they gave us x. So when they give you x, those are the easiest ones. So from there, we would plug in x to the other side. So this is 7. And then the hypotenuse is 7 root 2. Good. So legs are 7, hypotenuse 7 root 2. Okay, so go ahead and pause and try the other two examples to the right. And when you come back, I will show you the answers. Okay, so for the fourth one, we got that the legs were 9 and the hypotenuse was 9 root 2. And for the last one, the legs were 6 root 2 and the hypotenuse was 12. So we had to do a little bit of rationalizing and simplifying to find those legs. If you have any questions on those ones, make sure you write them down so that way you can ask me in class. So let's take a look at the bottom ones. Those are all of our 30, 60, 90 triangles. So we're going to do the same thing. So step 1, write our formulas. Step 2, make an equation. And then step 3 would be plug everything back in. So across from 30, if we check out the front, that was x. Across from 60 is x root 3. And across from the 90, 2x. So step 2 would be to write an equation. So we use the side that has the given number equal to the given formula. So x root 3 is equal to 4 root 3. So x equals 4. Once you know your x, we just plug it into the other sides. So this side over here would be 4. And the hypotenuse, 2 times 4 is 8. So for this one, we can't call our sides legs and hypotenuse because these two are different. So we'll call this one the short side, the one that's across from 30, and then the one across from 60 we'll call the long side. So our short side was 4, Our long side was given to us of 4 root 3, and her hypotenuse is 8. Okay, so let's go over here and try this one. So again, we start by filling in our formulas. So across from 30 is x. Across from the 60 that they didn't tell us was there, but we know it is because those would add to be 180, is x root 3. And across from 90 is 2x. So we were given the x root 3 side, so write your equation. Solve for x. And remember, if we get a radical in the bottom, we have to rationalize. So do all your rationalizing. So we get 9 root 3 over 3. And then since we have numbers that can divide, we divide them, so we get 3 root 3. So that means our short side is going to be 3 root 3. And our hypotenuse is twice as big, so that would be 6 root 3. So short side, 3 root 3. Long side, 9. Hypotenuse, 6 root 3. Okay, awesome job. I would like you to pause it and go ahead and try the last 3 examples, and I will show you the answers when you come back. Thanks. How we do, everybody? So for the second example, they gave us our short side, which makes life so much easier because we just had to plug in our x's in both spots. So we got 8 root 3 for long side and 16 for the hypotenuse. On the next one, they gave us our short side again, but this time it had a radical, so it had to do a little bit of operations to find the long side with those radicals, but we ended up with 21, and then our hypotenuse was 14 root 3. So for the last example, it was you do know it's a parallelogram because those angles make those lines parallel. So we have a parallelogram, so those opposite angles are congruent. So basically we have two 30, 60, 90 triangles put together. So don't get too scared. Okay, so fill in your formulas. We got that x was 8, so we plugged it in. So short side is 8, long side is 8 root 3. So remember to write down your questions and ask me in class tomorrow. You don't have to do your homework that's listed on your green sheet. We will work on that in class. Thanks. Werner out.